Hello everyone. This video Basics of Algebra 2 is in continuation with my previous video Basics of Algebra 1. In this video I'll be covering the topics like the like terms, the unlike terms, what is the degree of a polynomial, and how do we add and subtract to algebraic expression. So let us move ahead. Now what are like terms and unlike terms? Okay, suppose we take two terms as 2x and 3x. Okay, what do we see here? What is the variable part of 2x? The variable part of 2x is x and the variable part of 3x is x. And we see that in both these terms the variable part is same. Okay, and on the other hand, if we take an example, say 2xy and 3y square, the variable part here is xy and the variable part here is y square, and these are not same. Okay, so the terms in which the variable part is same, are called as the like terms. Okay, so here 2x and 3x are like terms. Okay, and in the second example we see that 2xy and 3y square, the variable part is not same, so these two terms are called as unlike terms. Let us take some more example. Say 8xy, 7xy and 5xy. What do we see in all these three? That the variable part is xy to all three of them, therefore they are like term. Okay, if we consider another example, say 8x square y and 7xy square. Now what is the variable part of 8x square y? The variable part is x square y and the variable part is here is xy square. Both the variable part are different, so they are unlike terms. So I hope it's very clear what is like and unlike terms. Okay, let us take one more example. 8 or 7x square y and 5yx square. Now here the variable part is x square y and here the variable part is yx square. Now the question is, are they like? Okay, so the answer is yes, they are like, because we know that a into b is same as b into a. Therefore x square into y will be same as y into x square. We have just changed the order in which we are writing the variables. Okay, so 7x square y and 5yx square are both like terms. So I hope the concept of like and unlike terms is clear to everyone. Now, when do we use the concept of like and unlike terms? Okay, so whenever we have to add or subtract, two algebraic expressions or polynomial, okay, then only the like terms are added or subtracted to each other. Let us see what does it mean. Whenever we have to add or subtract two algebraic expression or polynomial, then only the like terms are added or subtracted to each other. Now let us see an example. Suppose we take four terms, 7xy, 2x, 5x and 8xy, and we have to add the above terms. So when we try adding them, we will write 7xy plus 2x plus 5x plus 8xy. Now let us mark the terms which are like. We can't add a like term to unlike terms. So we see that 7xy is like with 8xy and 2x is like with 5x. Okay, so we add the like terms together. So whenever we have to add the like terms, now how do we add the like terms? Whatever is the variable part that is same, we just write that common variable part and we add the numeral part. So 7 plus 8 gives you 15. In this case, the same variable part is x. So just write down x, the variable part, and add the numerals 2 and 5 to give us 7. So your answer is 15xy plus 7x. Now can we solve any further? Can we solve this expression any further? What is the sign here? A plus sign. This means we are trying to add these two terms. What is the variable part of 15xy? The variable part of 15xy is xy and the variable part of 7x is x. Are the variable parts same? No. So they are unlike. So we cannot add them. We cannot do any operation further this step. So this is our final answer. Let us consider one more example. Okay, suppose we have three algebraic expressions as minus a plus 2b minus 3c, 4a plus 7b minus 9c, and 3a plus 5b plus 2c. And we have to add the above three polynomials. Okay, so how do we do it? You write the first polynomial minus a plus 2b and minus 3c. Okay, now comes the second one. We are doing it by the vertical or the column method. This is called a vertical or column method of adding the algebraic expressions. So now 4a plus 7b minus 9c. Let us see each of the term of this expression. 4a. 4a is like to a of the previous expression. So we'll write 4a below a, 7b below 2b and negative 9c below 3c. Remember, like terms below like term. 3a plus 5b plus 2c. So 3a comes below the like terms, 5b and plus 2c. And now when we will add all the like terms together. We will be adding minus a, 4a and 3s, which gives you a 6a. We will be adding 2b plus 7b, 9b plus 5b, 14b, and minus 3 plus minus 9c gives you a minus 12c, and plus 2c gives you a minus 10c. So what do we see here? That we are trying to add all the like terms first. So minus a plus 4a plus 3a we are trying to do. Okay, now a is the common variable part which is same. Just write down a and perform the addition on all the numerical parts. So minus a is nothing but minus 1. So minus 1 plus 4 is 3 and 3 plus 3 is 6, which we got here. Then 2b, a plus 7b and a plus 5b. The common variable part is b. Add all the numerical coefficient. 2 plus 7, 9 and 9 plus 5, 14. And in the third column, we have minus 3c, minus 9c and plus 2c. Okay, so the same variable part c is kept as it is and we just perform the addition on the coefficient, numerical coefficient. So minus 3 added to minus 9 gives you a negative 12. Negative 12 plus 2 gives you a negative 10. And here is your answer, 6a minus 14b and minus 10c. Okay, I hope this is clear how we add two algebraic expressions. Okay, now what happens if we have to subtract two algebraic expression? Okay, so we will see subtraction of algebraic expressions. We will see the subtraction also by the vertical or the column method. Let us understand it with an example. Okay, so let us take an example, say 6x square minus 3x plus 4, subtract this expression from negative 8x square plus 8x plus 1. Here also we will write the like terms below the like terms. Okay, so first we will write negative 8x square plus 8x plus 1. From this we have to subtract this expression. So 6x square is like with negative 8x square, so we'll write it below it. Negative 3x is like with 8x, so we'll write below it, and 4 below the constant 1. Now we have to perform the subtraction. Okay, whenever we have to perform the subtraction, we have to keep in mind that we have to change the sign of the subtrahend. This is the subtrahend. Okay, and we have to change the sign of each term of the subtrahend. So here the first term of the subtrahend is 6x square, and the sign of the subtrahend is positive, so we will make it negative. Next is negative 3x. The sign is negative, so we make it positive. And a plus 4 sign changes and becomes negative. Now we have to perform the regular addition. So we see when we try to add this column, x square and x square common variable part x square, we perform the operation on the numerical coefficient. So here we see that negative 8 and negative 6 combine to give you a negative 14. Okay, let us see the next column. The next column is 8x and negative 3x. So x is the same variable part, we write it down. Now 8 plus 8 and plus 3. We will consider the sign which we have changed. The change sign will be considered. So plus 8 and plus 3 gives you a plus 11. Okay, and let us move to the third column, which is simple 1, and 1 will be added to not plus 4 but minus 4. So it is minus 1 and plus 1 and minus 4, which gives you minus 3. So here important thing is that first thing is you write the like terms below the like terms. Okay, and when you have to subtract, you have to change the sign of each and every term in the subtrahend. Once the sign is changed, then you will consider the new sign and then you will perform the regular addition. Okay, let us just take one more example quickly. Let's say negative 9a plus 3b plus 2c. Okay, and subtract this expression from 7x minus 2a plus 3b. So we will write this expression on the top. So 7x minus 2a plus 3b. Now we have to write the subtrahend. So let us see. What is the first term of the subtrahend? The first term of the subtrahend is negative 9a. Is there any like term to it? Yes. So we have to write it below it, my negative 9a. Okay. Then we have 3b, which is like to this 3b. We will write it below it. And what about 2c? Is there any 2c term in this expression? No. So we can't write it below any of the terms of this expression. So we write it separately. Now we have to, this is the subtrahend. We have to change the sign of each and every term of the subtrahend. So negative 9a becomes positive, plus 3b becomes negative 3b, and plus 2c becomes negative 2c. And now we have to perform the addition the normal way. So we see here that 7x comes as 7x, nothing to be subtracted from it. Negative 2a and plus 9a. So a is the variable part and we will perform operation of negative 2 and positive 9, which gives you a 7. Okay, and here b is the common part, 3 and negative 3. Negative 3 and positive 3 gives you a 0, and this turns out to be negative 2c. So our answer is 7x plus 7a minus 2c. So this is how you perform subtraction of an algebraic expression, by writing the like terms below the like terms, changing the sign of each term of the subtrahend, and then performing the regular addition. I hope the subtraction is clear to everyone. So suppose if we get an algebraic expression, say 7x plus 3y. So this expression is said to be in its lowest form. Lowest form means we cannot further do any operation because 7x and 3y both are unlike, and we cannot perform any addition or subtraction on unlike terms. So we have to just leave it as it is. This is in its lowest form. Okay, and there is one more term which we use with algebraic expression very frequently, is called as the degree of a polynomial. Degree of the polynomial. What is the degree of the polynomial? The degree of a polynomial is the highest power of the variable. Let us take an example. Suppose we have an algebraic expression x cube plus 3x square plus 2x plus 1. Here our variable is, what is our variable? Variable is x. And what is its highest power? Highest power is 3. Here the power is 1, here the power is 2, and the highest power is 3. 3 is the highest power. Okay, let us consider one more expression. X cube plus x to the power 5 minus 3x square. The variable is x and the highest power of the variable here is 5. So this is 5. If we have an expression, say x square y square plus 7xy. The variable here is x into y. Okay, and what is the highest power here? The highest power will be the sum of 2 and 2. It will be 2 plus 2, which is 4. Whenever the variable part consists of two different variables in multiplication, the highest power is the sum of their individual powers. I hope this is clear. Okay, so here x square y square, the x and y two variables are in multiplication. Okay, since they are in multiplication, the highest power will be the sum of their individual power to give a 4. And this highest power is known as the degree of the algebraic expression or the polynomial. Okay, so I hope degree is clear to everyone. Whenever we have algebraic expression with a degree 1, then we call it as a linear expression, a quadratic expression, and cubic expression, and so on. So algebraic expression x plus 4, what is the degree here? The degree is 1 because the highest power of this variable is 1, and this is a linear expression. It's called linear expression. It has got a degree 1. Expression like x square plus x plus 4, degree is the highest power of the variable x, which is 2. So this is called a quadratic expression. And if we have x cube plus 3x plus 5, the highest power of the variable x is 3, and such expressions are called as cubic expression. Okay, so I hope the like terms, unlike terms, addition, subtraction of the algebraic expression and the degree is clear to everyone.